Good day, ma'am. Good day, classmates. So, we are the group 10 and we will be reporting by the topic of three-phase alternator. A three-phase alternator is a synchronous machine that converts mechanical energy into three-phase electrical energy through the process of electromagnetic induction, ensuring consistent and reliable source of three-phase easy powers for diverse electrical system. So, a three-phase alternator is a synchronous machine. So, by the meaning of synchronous is mo na sidyang magkadungan siya og function bali kuan kanang agma function sa mga kana sa nga machine is nagkadungan sila. So mo na ang meaning sa synchronous sa kanay pod nga three-phase alternator. So a three-phase alternator also called a three-phase synchronous generator. So gitawag sa synchronous kay nakadungan malagi sila og function or nagkasabay sila og kuan ba kanang lihok sa ilang mga kuan sa lihok sa machine. So it has a stationary armature and a rotating magnetic field. So in the three-phase alternator, the rotor winding serves as field winding, is energized from DC supply, and alternate north and south poles are developed on the rotor. The purpose of a three-phase alternator is to produce a balanced and efficient power supply for various applications, including industrial, machinery, power distribution, and electronic grids. So in addition po sa akong mga nakuan kanang nag-gather nga information about aning application sa three-phase alternator is magamit siya sa power plants or large scale electric generator system. So it is useful and kuan kanang nice nga invention po ni nga three-phase alternator because dako siya impact sa kuan society. So dako sa gamit labi na sa pag-create og mga electric o maka-supply po og makuryente sa kuan sa society lagi. Components of three-phase alternator. So a three-phase alternator consists of three coils windings. Contrary to a single-phase alternator which has one winding. An alternator aims to produce easy alternating current stator output with two basic winding designs, delta, wound, and WYE style. Each of the winding has a separate phase of the current. Rotary currents will with three phases. So, kaning three-phase alternator is nasa jay different kind of kuan mga alternator. So, muning mga panganila kaning three-phase alternator A, kaning three-phase WYA connected, yung three-phase delta connected. So, sa picture nga na-present diriya is muni ang mga different kind of three-phase alternator or ilang mga design pod. Okay. So, each of them have kuan different kind of functions lagi og capability pod. So, alternators in general exist of the two types, single-phase alternators and three-phase alternators. Though the latter is more efficient than the former, while based on applications and output voltage, alternator exists in different types, including marine alternators, brushless alternators, diesel electric, locomotive alternators, and high-low voltage alternators. Revolving armatures and revolving field alternators are indeed two other types of alternators. Nonetheless, the kind with revolving armature is rarely used. The reason is that armature usually remains stationary. So, stationary means kuan kanang remain ra siya nag-remain ra siya or nag-remain ra siya. Application of the three-phase alternator. So, for now we'll be discussing the application of para asa kajuning three-phase alternator sa kani siya nga topic. So the three-phase alternator proves its usefulness majority in data centers and telecommunication sectors. That is because alternators can generate easy power with better dynamic performance, higher efficiency, lower temperature rise, and improved quality standards. Besides that, it is also used for power generation, railway industry, mining industry, and other industrial application. To name a few, the high efficiency of the three-phase alternator makes it ideal for all these industrial industries, and many more. So, ang application sa three-phase alternator is very helpful sa different kinds of kanang field, no? Labi na sa mga mining, sa kaning railway, o sa daghan pang mga different kind of application. The working principle of the three-phase alternator. After knowing the types and application of the three-phase alternator, it is wise for you to understand its working principle. Thus, let's introduce the structure of the three-phase generator first, and then introduce how it operates from simple to profound. So the structure. So the basic structure of the three-phase alternator or synchronous generator consists of three identical embedded coils attached to a central stator core as the circumference of the entire network. So furthermore, the coils are 120 degrees apart. A neutral line also exists that interconnects the three coils. The other end of the coils is outgoing and is called the phase line. Three-phase voltage. Since we are talking about three-phase alternator, each coil creates its separate phase or voltage. So they have different separate of phase or voltage, which might be the same in magnitudes in each coil. Similar to the angle separating them, the phases are also at a difference of 120 degrees from each other. The voltage magnitude induced in each phase relies on the rotor flux, the number position of the phase conductors, and the rotor speed. And in addition, the induced voltage frequency matches the rotor speeds per second due to only 2 poles. So how voltage control for an alternator is accomplished? So voltage can control be achieved by the use of an automatic voltage regulator, or AVR for short. The device exists at the heart of electronics such as alternators. It helps regulate output voltage by controlling the excitation current of the generator AC exciter. So how the field of an alternator is established? So the rotor is one of the critical components that generate power in the three-phase alternator. So ang rotor may pinaka-critical component sa pag-generate sa power in the three-phase alternator. So it spins the stationary coils winding around a fixed iron core. The stator armature, the magnetic field from the rotor subsequently produce an alternating current in the stator. So armature winding of alternators are different from that of the DC machines. Basically, three-phase alternators carried three sets of windings arranged in the slots in such a way that there exists a phase difference of 120 degrees between the induced EMF in them. In three-phase alternators, the 6 terminals are brought out, which are finally connected in star or delta, and then the 3 terminals are brought out. All the coils used for one phase must be connected in such a way that their EMF helps each other. An overall design should be in such a way that the waveform for an induced EMF is almost sinusoidal in nature.
Operation of three-phase alternator. A three-phase alternator works on the principle that an electromagnetic force or EMF is induced in the conductor when a conductor's flux alters. Essentially, the rotor takes turns at a constant speed. When the rotor is rotated, for example, in anti-clockwise direction by a prime mover, engine or turbine or etc., the stator winding serves as our armature winding, is cut by a magnetic flux of the rotor poles. Due to the electromagnetic induction, an EMF is induced in the armature winding. The induced EMF is alternating one because the north and south poles of the rotor alternately pass the armature winding conductors. The induced EMF magnitude is based on the rotation speed and the exciting current. So, construction of three-phase alternator or synchronous generator. So, the other term for phase alternator is synchronous generator. So, alternator consists of two main parts. So, nakuno siya ang alternator na ay duha ka main parts. Statedly here that the first part is stator and the second part is the rotor. What is stator? So stator is the stationary part of the machine. From the word stationary, so di siya mulihok. Mag-stay dire siya. It carries the armature winding in which the voltage is generated. So ang trabaho sa stator is siya ang mo carry sa armature winding para ang voltage ma-generate. The output of the machine is taken from the stator. So the rotor is the rotating part. So another part sa alternator is the rotor. So giingon diri nga ang rotor kuno is the rotating part of the machine. And it produces the main field flux. Stator construction. So first phase sa construction is the stator construction. So stator construction, the stationary part of the machine is called the stator. So gisulti na ganina. It includes various parts like stator frame, stator core, stator windings, and coiling arrangement. So first part ko niya is stator frame. What is stator frame? It is the outer body of the machine made of cast iron and it protects the inner parts of the machine. So kibali kung sa kanang motor pa ni siya ang kaha sa motor kanang or sa may lang example ha. Basta siya ang nasa sa gawas nga part, outer part. Kibali siya ang nag-protect sa machine. Nga na. Next is the stator winding. Stator winding slots are cut on the inner periphery of the stator core in which three-phase or one-phase winding is placed. Enameled copper is used as winding material. So mostly ang stator winding is made of copper or enameled copper. The winding is star connected. The winding of each phase is distributed over several slots. When the current flows in a distributed winding, it produces an essentially sinusoidal space distribution of EMF. Next one is the rotor construction. So, ang construction sa rotor. So, the rotating part of the machine is called rotor. So, ang gisulti na ganina nga magmumabol nga part sa machine. So, there are two types of rotor construction. So, nako siya duha ka type, namely cylindrical type and cylindrical rotor type. Stator core. The stator core is made of silicon steel material. It is made from a number of stumps which are insulated from each other. Its function is to provide an easy path of the magnetic lines of force and accommodate the stator winding. So ang iyang function is mag-provide para mapadali ang path of magnetic lines of force and accommodate the stator winding. Load test on three-phase alternator. Alternators generate an AC voltage whose frequency depends entirely upon the speed of rotation. So ang pag-generate sa AC voltage mag-depend siya sa frequency sa entirely upon the speed of rotation. So ang pag-generate ko na sa AC voltage magdepende siya sa kakusog sa taliyok. The generated voltage value depends upon the speed. So ang generated sa giingon na ang value sa voltage magdepende siya sa speed, the DC field excitation, and the power factor of the load. The terminal voltage of an alternator changes with load. As the AC-DC field excitation of an alternator is increased, its speed being held constant, the magnetic flux and hence the output voltage will also increase in direct proportion to the current. So, sa gingon diri nga kung mo increase ang idang DC field excitation, ang speed kuno nara sa constant. Ang magnetic flux. Pero ang output voltage will increase siya direct proportionally to the current. However, with the progressive increases in DC field current, the flux will eventually reach as high enough value to saturate the iron in the alternator. Saturating iron means that there will be a smaller increase in flux and it gives an increase of DC field current because the generated voltage is directly related to the magnetic flux intensity. It can be used as a measure of the degree of saturation. When the alternator delivering 4 rated output voltage is suddenly subjected to the short circuit, very large currents will initially flow. So ang alternation delivering full rated output voltage kay mas suddenly subjected to a short circuit kung sabot nga na short circuit metabo na ako dako nga kanang current nga mo-flow. However, these large short circuit currents drop off rapidly to safe values if the short circuit is maintained. So the output voltage of an alternator depends essentially upon the total flux in the air gap. So ang output voltage kuno sa alternator magdepende ra po siya sa total flux sa air gap. At no load, this flux is established and determined exclusively by DC field excitation. Under load, however, the air gap flux is determined by the ampere turns of the rotor and the ampere turns of the stator. The latter may aid or the oppose of the MMF or magnetomotive force of the rotor depending upon the power factor of the load. So, ang MMF kuno sa rotor magdepende ra siya sa power factor sa load. Leading power factors assist the rotor and the power factors oppose it. So, ang leading power factors kuno assist by rotor. Load test is performed by driving the alternator at its rated speed and increase the field excitation till the armature voltage reaches its rated value. It increase the load in the alternator terminals. During this process, alternator armature current will increase. Terminal voltage will vary according to the type of the load. By observing the input and output of an alternator at each load, we can calculate the corresponding efficiency and regulation.
The advantages of a three-phase alternator. Three-phase system has many advantages over a single-phase system. Let us see a few of them. For a given dimension of the generator, three-phase machines produces high power output than a single-phase machine. So, ang pasabot ani is, compared sa single-phase system, mas dago pa ang power output sa 3-phase kaysa sa single-phase. And number 2, for the same capacity, 3-phase alternators is smaller in size when compared to a single-phase alternator. So, compared po sa single-phase alternator, mas gamay pa ang kadag-on sa 3-phase alternator kaysa sa single-phase alternator. So, in short, ang 3-phase alternator is gamay pero mas kusog mo produce power. However, 3-phase alternators also have some cons. First, the initial purchase cost can be higher than the single-phase alternator. So, ang pasabot po ani is, ang 3-phase alternator is mas mahal pa dun isang initial cost compared sa single-phase, kay mas complex pa manggod ang 3-phase alternator kaysa single-phase man ang mas mahal. And 2, they can be more challenging to maintain and repair as they have more parts that can break down. So mao itong yun nga mas complex pa ang 3-phase alternator mo nang mas tago po dong chance nga kung maguba tahan sa nun. And pangatulo, 3-phase alternators can produce more noise than a single-phase generators, making them less ideal in residential settings. Ang 3-phase alternators pod is mas banha pa ni siya kaysa sa single-phase. Manang dili siya angay gamiton sa mga residential, pero pwede rin siya sa mga dapat siya gamiton is sa mga mga factory na mga industrial settings, dili sa residential.
Now moving on to the next topic, troubleshooting the most difficult problems of three-phase alternators. It's always important to identify the real cause of problems and not just to replace it entirely. Alternator windings have a different appearance in all these failure situations: single-phase burnout, overload, and valence voltage and voltage spikes. Voltage spike damage occurs more often in alternators controlled by variable frequency drives. These winding problems may be found in a three-phase alternator. First is the shorted turns, the ground, 3 the face-to-face short, 4 the open winding, and 5 the submerged alternator. 6 a sorted rotor problem, a sorted rotor problem consists of 5 rotor problems. First is the open rotor bars, second open end rings, third misaligned rotor or stator iron, fourth rotor drag
rotor dragging on the stator, 5 rotor loss on shaft. These problems require replacing or rewinding the motor. Now, first, the shorted turns. A short is a common winding breakdown and it requires rewinding or replacing the alternator. Shorted turns are caused by naked coil wire, high voltage spikes, conductive contaminants, overheated winding, age insulation, and loose vibrating coil wires. Power consumed by the circulating current increases the amperes of the faulty phase, making it easy to identify the problem. Second is the ground. When an alternator is grounded, the winding is shorted either to the laminated core or to the alternator's frame. The problem is usually found in a slot where the slot insulation has broken down. Water is the most common cause of ground winding. A solid ground requires rewinding or replacing the alternator. Some causes of slot insulation breakdowns are overheating, conducting contaminants, lightning, age, pressure of a tight coil fit, hot spots caused by lamination damage, and excessive coil movement. 3. Face-to-face short. A face-to-face short is caused by insulation breakdown at the coil ends or in the slots. This type of fault requires rewinding or replacing the alternator. Voltage between phases can be very high. When a short occurs, a large amount of winding is bypassed. Both phase windings are usually melted open, so the problem is easily detected. Among the causes of interface breakdown are contaminants, tight fit, age, mechanical damage, and high voltage spikes. Coils that form the poles for each phase are placed on top of each other in all three phase motors. 4. Open winding. A common cause of an open winding is undersized lead lugs. Charred connections in the alternator's connection box are a sure indication of this problem. Open windings are also caused by shorted turns, face-to-face shorts, ground-to-frame shorts, faulty eternal coil-to-coil connections, severe overloads, and physically damaged coils. These faults requires rewinding or replacing the motor. An open winding will show several different symptoms depending on the motor's eternal connection. A micrometer is used to identify this problem. A motor with a high number of parallel circuits, that is 4 and 8Y, will show less power loss when one circuit is open. An overloaded motor operating on 490 volts, however, often will have no sign of burned wires before its winding melt open. In either case, the overload protection isn't working and the alternator should be rewound or replaced. 5. The submerged alternator. If a three-phase alternator has been submerged in water but not energized, there's a good chance it won't need rewinding or replacing. 6. The assorted rotor problems. Now, we all know that assorted rotor problems consist of 5 rotor problems. First is the open rotor bars. Open rotor bars or end rings usually necessitate replacing the motor. They can be repaired, recast, or rebarred if it is economical. It's important that any replaced metal will be the same as the original. Open rotor bars are usually caused by overload burnout, arcing in the slot from the shorted winding, loose bar vibration, thermal growth stress, flaws in bar material, and poor connections with end rings. Open end rings muse uneven torque and some power loss. A ring with one open spot will soon develop more open spots. Each time the open spot crosses a 90-degree spot between poles, the current will double in the ring area between the next two poles. Cause of open end rings include the following: flawed casting, motor burned out from overload, and mechanical damage. 3. A misaligned rotor or stator iron. A motor with misaligned rotor will draw high amperes and will lose power. The magnetic path becomes distorted, causing the magnetizing amperes to increase. The stator windings will char and resemble an overload burnout. Possible causes of misaligned rotor include wrong bearing shim placement, bearing not established correctly in the shaft, wrong bearing width, captive bearing not held as original place, and belts interchange. Stator core shift on its shells, a rotor shift on its shaft, and a rotor place with not the exact same specifications. Rotor dragging on the stator. If the rotor drags on the stator and bearings aren't worn, it's common practice to skim the rotor on the lathe. The process increases the air gap, which increases the no-load amperes. The increased amperes are similar to a misaligned rotor and stator iron. The magnetic circuit is degraded, so it takes more amperes to magnetize the motor's iron. The motor will run hotter than normal because the motor is drawing more magnetizing ampere. If the load is at maximum or there are any adverse conditions such as low voltage or frequent starts, the motor should be replaced. There will be some permanent power and efficiency loss. Last, the rotor loose on shaft. A loose rotor on a shaft makes a rumbling or vibrating sound. If the motor has operated this way for a very long, a red dust will form between the shaft and rotor iron. The decision to repair a loose rotor depends on the price of a replacement motor and the importance of the motor in the plant or operation. There are options for this problem. First is the rotor can be replaced. Two, the rotor can be bored out and a new shaft fitted to it. Or third, a thin metal wedge can be driven between the shaft and rotor to secure it. Wedging is the rotor may offset it enough to make it drag on the stator. In most cases, it is more economical to replace the motor.